Welcome to Breadboarding. In the previous video we managed to get the hard disk working and also the VGA ISA Bus video card, but there are some artifacts, so you can see here there's some lines here not quite there, and also some colours in some of these sort of circles down here where the reading and writing to the video RAM wasn't quite working. So during this video we're going to look at what I've been doing to try and improve this. And we're also going to be doing is looking at adding a PS2 mouse and seeing if we can load up early versions of Windows. So probably looking at Windows 1 and 2 initially. So this is the final stage really in the high level plan for our Breadboard PC version 2. So this is an improved version of the initial Breadboard PC I built more than a year ago. So by finishing the last two things off here, we should be coming pretty close to the end of the project. So if we just take a look at the Breadboard PC, it's booted up into MS-DOS here. Now one of the problems I've been working with is the scrolling doesn't quite work properly for some reason. So if we just type this test file here, all this does is just outputs rows of letters. Now it writes the video RAM absolutely fine, no problem writing the video RAM, but when we do scrolling then there are some timing issues that are causing problems. So if I just do two new lines, and you can see that the scrolling is not quite right, and we've got the odd character appearing on different lines. So the reason why I've used these different letters is so it just makes it a bit more obvious when either there's a gap because we've got a space rather than the letter, or whether you can see there the letter A on the very top line has obviously been written to the wrong place. So there's obviously some problems going on here. So what I've done with this test.txt, which is the before here, what was happening originally, I was getting a lot more of these problems. So you can see here there's an awful lot more characters missing and not being done correctly. And this was actually before I added some extra buffering on the ISA bus card that I've added. So what I did is added some address buffers actually between the main system bus and the video card. And this has actually improved it quite a bit. However, it's still not quite right. You can still see there's the odd characters coming out on stray lines, and that some of the attributes sometimes are getting changed. And so I've been looking at this now for probably up to 5 weeks, and I've gone through quite a lot of different changes and improvements, but I'm still suffering from this problem with the VGA ISA bus cards. Now I still have my original CGA video card that I built, and so what I might do in a future video is go back to that and see if I can get that working nice and smoothly. But I was just going to try and finish off with the VGA cards initially. So I don't think it is actually a problem with the video cards themselves. I think it's just some sort of esoteric issue to do with the timing on my version of the Breadboard PC, but I haven't really been able to get any further than we've got here. So let me just take you through a few things that we've actually done during this, but just go and have a look again at some of the tests that we were doing previously. The VGA Test Bench is the utility I was showing in the last video. I'm just going to go through a couple of the screens that were causing problems last time, which are now looking a bit better. Now, I'll just go and show one or two of the screens which have improved now. This one is looking better. The 400 line one takes a little while, so I'll just speed this up. It takes about 3 minutes for that to appear. So this is the image I started the video off with, and you can see this one now is actually much cleaner. There aren't any missing lines, and it generally looks a whole lot better than the previous one does. Again, this one is pretty clean. However, still a number of the tests on here are not quite working properly. Certainly anything to do with reading the video RAM is still causing problems. Just have a look at the text. You can see the text comes out quite nicely, but as soon as it tries to scroll it, then this is where the problems occur. You see that's just scrolled up a couple of lines, and that's where it's got a little bit messed up. Again, this one here should be a fairly regular mesh of squares, and you can see that although it's doing a reasonable job, there are still areas on the left hand side and generally all over where the reading and writing to the video RAM is not quite right. I'm just going to show one of the test patterns here, which show, and I'm going to record on Logic Analyzer just to show you what all these changes that have done have been. So this 480 line bar is actually using graphics, and you can see here that the interference we got there seems to be because either the addresses that we're reading and writing to are not coming out quite right. See, there's a bit of bleeding of the pixels going into the other pattern. It should obviously just all be the same color. So if we have a look at the Logic Analyzer output for this, there's one here that I've focused in on just one area. So what we can see here, we have the bus ready input coming in from the video card, and you can see that between A1 and A2 here, so this is about 310 nanoseconds, and you can see that on the read here, down the bottom here, we can see that we've got a memory read occurring at this point in time. So the memory read is this period here. But you can see that the output from the VGA card is actually quite messy. And this is what's caused some of the problems, and I've had to try and clean this up in some of the logic. And basically what comes out of this is through the wait state logic, the ready wait signal is the thing that goes to the clock controller, and the clock controller actually produces the CPU ready output. And when CPU ready goes low, this is effectively pauses the CPU to actually give it a little bit more time to do the read. So if we actually have a look at perhaps one of the other signals knocking around here, if we look at an I/O read, for example, now the I/O read is extended beyond the normal read period by the wait states, but you can see if you look at the top right hand side up here, this is about 600 nanoseconds for an I/O read, whereas if we look at this one here for the memory read here for the video RAM, then in fact this is about 1.06 microseconds. So it's been extended by a fair bit more, and you can see that the A1 to A2 there is about 310 nanoseconds. Now, part of all the complexity of sorting this out was trying to make sure that this ready wait signal didn't have any blips on it at all, and also that the problem we were having when the VGA card would keep the bus ready low and it effectively hang the PC forever, then what we've now got is this signal down here that we are actually making use of the ready wait 8 here and ready wait 9, that if the signal goes on beyond a certain period of time, it will actually cause a reset so it doesn't actually hang. So with all those changes being done, then the system is a lot better than it was, but we can still see that the memory timing isn't quite right, but it is a bit messy with the outputs coming out of the video card. You can see here for a write, so we've got memory write here rather than the memory read, you can see that the output from the bus ready is much cleaner for the write. So there does seem to be something strange going on here. I've tried all the different things I could think of, and I don't seem to have made any difference. So when we actually look at the data here, you can see here this is a particular read. This read period is about 1.06 microseconds. And you can see that in fact that if we didn't have these bus ready period here, you can see that in fact the signal here from B1 to B2 is about 330 nanoseconds. So the 0xFF then does become F8 for the rest of that period of time. So you can see that if we weren't extending this, if this was only taking perhaps 240, 300 nanoseconds, which is what the default timing would be without any extended wait states, then we would potentially miss the data here. We don't appear to be missing the actual data anymore, but it just seems to be a problem with the actual addressing itself, that the video card is not picking up the addresses correctly all the time, but I haven't been able to get to the bottom of what's causing that. So it's as good as what we're going to get for the moment. In analysing this, I put on the various CPU clock cycles. So we have the T1 phase where the address is output, T2, T3, then when we have wait states, and then this red line here is where we're actually getting the reset for the latch. And basically what I had to do is to mess around with the PLDs to ensure that if we had this period of time lasting too long, then in fact it would actually reset the flip-flop so that this bus ready didn't stay low forever. And in fact, the wait states you can see here with the T1, T2, T3, the wait states, the ready line on the CPU needs to be low on this rising edge here. So in going through all this sort of stuff, I've gone through and modified the various PLDs. If we have a look at the PLD changes, this is comparing the version 7 from the previous video with version 8 for this one. So this has been created for video 25. And you'll see here that some of the ready wait 2 and 4 has been changed to 1 and 8 because we're using these signals for doing the reset of the bus ready when it goes on too long. And there's all sorts of changes here. So I've changed where I was doing some of the memory refresh logic. I've reused all of that stuff for the various flip-flops I require for stopping bus ready from remaining low for too long. The ready wait reset is now based on clock cycle 2 and this ready in 3, and the ready wait 7 also provides a level of smoothing out some of the oscillation in the ready wait. So this has taken quite a while to get through all of this, but what it now means is that the output from the video card, the bus ready signals, is now being honoured by the wait states for the Breadboard PC. It still hasn't solved everything, but it's about as good as I can get this for the moment. Then we'll see that we've got some of the resets and things have then just been modified to account for this. And these ones down the bottom here, the ready wait 8 and ready wait 9 are related to resetting the bus ready signal so that we don't get this sort of bus ready being held low forever. Now, one of the other tests I've done is actually with the video RAM loaded with this data. What I've done is I've dumped the video RAM into SREC format. And the strange thing I was finding is that the data being read out of the RAM again is getting all messed up. So if you just have a quick look at some of the SREC output from this here, so we should actually see that we've got all the characters A, B, C. So A is 41 hexadecimal, and the attributes for each one should be consistent, but in fact what we'll see is that this has actually got quite messed up. So what I've done is I've dumped the SREC file from here, and because we've got a blank line on the top, so we'd expect to have spaces, and 07 is the normal attribute, but you can see here where I've highlighted in orange we've got an FF there, and then where we should have the text for the command line here, then there are some spaces here, and then when we get down to the blocks of A's, B's and C's, you can see that even though we get quite a lot of A's coming out, there are the odd spaces coming here. And I suspect what this is actually the address that is actually being accessed by the video RAM is probably not correct. And I have actually tried to ensure that all the address information is completely correct going to the video card with buffering and all sorts of other things. But you can see here that we're getting quite a lot of spaces coming out all over the place. And that really this probably indicates that there are some of the address lines are probably getting some of the data from another video page or for somewhere else in the memory map. So it looks like this is a problem really with the perhaps the changes in the row and columns in the RAS-CAS in the video card, but I can't seem to change anything to actually improve it. And you'll see that this then goes on for all the other ones. So we've got the B's and the C's and the D's here. There's not just one area, it's actually everything. And the irony is the writing to the video data is absolutely fine. It's the reading that is the problem. So I've come to the conclusion there is a 32-byte cache in the video card for reading data. And all I can assume is that because the writing works okay, is that that cache for some reason is not working properly. So for the moment, I'm going to park this. I may come back to it in the future. But what I'm going to do is to carry on now, trying to finish off the series, and we'll come back to looking at the VGA video card, perhaps when I manage to make some progress on it. So let's take a look at setting up the mouse. So we're going to be enabling the PS2 mouse. Now the first mouse was produced by Douglas Engelbart in 1964, and the original mouse is actually in a museum not entirely sure where that is. So the first mice really for 1973, Xerox. Apple Lisa had one in 1983. Microsoft mouse, PC serial mouse was available from 1983. Then came the bus mouse, and then the PS2 mouse came out around 1987. Now, PS2 has been superseded by USB and Bluetooth since then, but you will be perhaps familiar with older PCs had the green and the sort of purple PS2 ports for the keyboard and for the mouse, and you can also get USB to PS2 converters. So quite a lot of keyboards with an appropriate converter like this, you can plug in a USB keyboard and it will still work with a PS2 port. Now, the design we've used here is based on Sergey Kiselev's XI8088 design, and so I went through this in the previous series, so I'm not going to go into great detail about it. But basically, there are the two outputs for the auxiliary channel, which is known as the auxiliary channel in the original PC, but it's primarily the mouse port. And we need to worry about wiring up the interrupt 12 and ensuring that the other pins have been wired up properly. Now, we did that earlier on when we were wiring up the keyboard, so this should hopefully all be correct. So what we need to do is to check that the mouse interrupt 12 line is connected. We also need to enable the mouse aux port in the BIOS. So there is a PS2 mouse definition we need in our config file, and we need to reassemble the BIOS and burn it into EPROM. So I've already done that. In fact, if we look at the configuration file for the BIOS, you can see here that I've actually had to change the model byte. This was what I covered in the previous series, that by setting the model byte that helps the mouse driver determine what type of PC we've got, we actually are telling it that we've actually got an IBM PS2 Model 50, I believe, is the model bytes that we've got here. There's also the enabling the PS2 mouse here, and we also need to have the extended BIOS data area. This needs also to be set. This extends the BIOS data area by about 1 kilobyte at the top of memory and is used in particular for the mouse support. So that's already been assembled and burnt into the BIOS, so the mouse support should be all ready to go. Now we will need to use the mouse driver. I had all sorts of problems in the first series getting the Microsoft mouse drivers to work, and I'll cover what changes needed to be done to the BIOS to get that to happen. And we also need to copy the mouse driver file from Windows 2.03 or later into the Windows 1.0 setup in order to enable the mouse support for PS2 mouse in Windows 1.0. And then we just have to run the setup for the Windows 1.0 with the Microsoft Mouse Bus serial option. So there's a summary here from the earlier series. So the Qt mouse driver works both in DOS and Norton Editor, but I couldn't get the Microsoft mouse drivers to work, either the Microsoft Mouse 7, 8 or 9. Although theoretically the Microsoft mouse drivers were not required in Windows, if we didn't actually have the mouse drivers detecting the mouse, then there's a good chance that the Windows mouse drivers wouldn't pick it up. So I covered this in more detail in the earlier series, so I'll include links to the videos in the description below, and if it's able to, the link in the top of the screen up here. So when you move the mouse on the mouse pad and you move it to the left-hand side, there are a lot of different parts that get involved in this. So primarily the mouse is obviously plugged into the keyboard and auxiliary port controller. So this is our 8242 dedicated chip, and that is on the port 60 and 64. Now, the bits that actually interact with this, we've got the PC BIOS, we've got MS-DOS, we've got the interrupt vectors in the PC BIOS, we've got the keyboard controller that runs on interrupt 16, we've got the video on interrupt 10, and we've got the hardware interrupt 12 for the mouse, which happens to use the interrupt vector for 7.4. Then there are some mouse extensions which are using interrupt 15 and a special function C2, so this is a sort of a BIOS extension, and there's extended BIOS data area, which is what is used by the mouse for actually supporting it. Then there are interrupt vectors actually in MS-DOS, and the interrupt 21 DOS functions, And what mouse.com does is has to do quite a number of things. So when you first kick it off from the command line interface, the initialization creates some interrupt 33 mouse functions. It also intercepts the interrupt 10 video BIOS call so that the mouse can appear on the screen. And so the mouse driver will handle drawing the mouse on the screen in the various modes, whether it be text or graphics. Then there's a terminate stay resident part of the mouse driver that stays in memory once initialization's been done. We have the programmable interrupt controller for interrupt 12. So when interrupt 12 is fired by the keyboard mouse controller, this raises an interrupt to the BIOS. We get interrupt vector 74, which again goes to our TSR, that then goes to interrupt 33, that then calls the mouse extensions to find out what's going on. It then requests the data from the mouse and then tells the video data to move the mouse pointer on the screen. And that all has to work properly for the mouse to work. So in order to get that working was quite complicated in the previous series. But in fact, what it turned out, what I needed to do is, as we've already done, we've set the model byte in the BIOS to pretend that it's a PS2. I think it's a model 50, which is what we've set it to. So this is one of the mid-range IBM PS2s. And there was an issue that with the Microsoft mouse drivers didn't like some of the scaling functions. So in fact, I just had to comment out one line out of the BIOS to do with sending the scaling information to the mouse. It turned out that the Qt mouse driver didn't do anything to do with scaling, but the Microsoft ones did. So in fact, then the Microsoft mouse driver 7 and 8 worked, but I couldn't get the 9 working, but I was able to get mouse support working in Windows 1, 2 and 3. So in order to get Windows 1.0 working with the mouse, what we needed to do is the original Windows 1.0 documentation here and the startup screen. This is from the CGA video card in the earlier series. I will be installing this in a few minutes. And we can see here that the reserved for the extended BIOS data area would expect to see this amount of memory appearing in the BIOS startup when it's enabled properly. And then when we're actually installing Windows 1.0, we need to select the Microsoft Mouse bus serial option. And as long as we've copied the driver file from later versions of Windows into here, then it should also support the PS2 mouse as well. What I'm going to do now is to format a blank hard disk, and we're going to install Windows 1.0 on it and see if we can get the mouse up and running. So what I'm going to do first of all, I'm going to replace the SATA drive that I've been using up to now, which has got a number of versions of Windows installed on it from the previous series. So I've wiped the new disk I'm going to be using, so this has already had everything removed from it. So I've used the Windows 11 disk part and done the clean on it. You need to be very careful to make sure you select the correct disk, otherwise you might wipe your whole operating system. What we're going to do now is to boot MS-DOS 330 from floppy disk. We're going to use the fdisk utility, create a primary DOS partition. It will only be about 4 cylinders, that's about 32 megabytes. We're going to set it to be the primary partition to be active and also reboot, and then we'll do a format C/S, and that should copy the basic MS-DOS files needed to boot off the C drive. Then I'm going to copy some more files and things on there. I'll do that from another computer because it's just easier to copy the files on there from another hard disk. Just going to boot up the Breadboard PC. So it's detected the 500 gigabyte SATA drive there. It's in a SATA to IDE converter. I'm going to do fdisk first of all. Display partition information. So it says that there is a disk drive there, but there's no partitions defined, which is what we expect. Now we're going to create the primary DOS partition. We're going to make it active after we've finished. There is a little delay as it goes off to look at disk. Now we need to reboot. Now we just need to do format C:/S. That's finished. If we just clear the screen, do check disk C. So we can see there that we've got two hidden files, which has got the io.sys and ms-dos.sys, which are the MS-DOS operating system files. Now what we need to do now is to copy over. If we just have a look at what we've got here on this disk, I'm just going to copy everything over here. And because we've got X copy on here, we can just do X copy. I might just clear the screen first so we don't get into scrolling problems. X copy star.star C colon. We do a /s, which means it should do subfolders as well. So once it starts scrolling, you can see it sort of messed up the screen there a little. Let's just clear screen and see what files we've got there. There's a little delay there because it's looking at all the empty clusters there. So we're just going to use Norton Editor to edit the config.sys. So just going to change the A drive there, the C drive, and save that. Then we'll open the autoexec.bat once we can find it. There we go, autoexec.bat, and we'll just change those to be the C drive as well. We won't comment in the mouse for the moment. Reboot. That started MS-DOS 3.3 from the hard disk. Just run up the video test bench, just do a quick test, make sure things are working okay. It seems to be working okay. Now what I'm going to do is I'm going to go and copy all of the Windows 1, 2 and 3 installation files onto the disk and some other things. I'm going to do that from another PC. It's just a bit easier than using lots of floppy disks. When we come back, we will install Windows 1.0, Windows 2.0. Okay, so that's booted up, and what I'll just do is to show all the files we've got on here. We basically got the Windows 1.03, 2.03 and Windows 3.0 installation files. I've also added the Qt Mouse driver and the Microsoft Mouse 8 driver in there. So we should have everything we need now to install Windows. I'm going to do it without the mouse to start with. So we're going to need to do Windows 1.0 first. Now the only issue with Windows 1.0, you can't install it off files in the C drive. What you have to do is install it from the A drive. So what we need to do is disable the A drive and then to use the substitute command to point the A drive at the Win103 install directory. So I'm just going to do that and then we'll come back and then we'll install Windows 1.03. We just need to disable the floppy disk drive, F0, right. We can see now that it's tried to boot off the A drive, but it's not there. So now we're in MS-DOS 3.3.0. What we can do now is to type in subst A colon C colon / win 103. We now should be able to go to the A drive. And we can see here, apart from the fact that we've got our video scrolling issue, you can see I've got our Windows installation files there. We're just going to type setup. Select UK for the keyboard. We're going to select the Microsoft Mouse Bus serial mouse. We may need to copy the driver over from Windows 2 for it to detect the PS2 mouse. I'm going to do it as CGA to start with. Say no for a printer. Okay, so we've installed Windows 1.03. So we're just going to try typing in Win first of all and see what happens. Now we can see that the video problems we've got with the video card reading the existing RAM is causing this problem, but we can see that we can actually navigate the system a little bit. It's a little bit messy, but I may look at restoring my CGA card that I built earlier on in the series and install that to get that working. But this looks like it is doing something here. We just need to now see if we can copy across the mouse driver to see if we can get the mouse working in Windows 1.0. If you just look at the mouse driver first of all, that's the current Windows 1.0 driver, so we'll just rename that. Okay, and then we will just copy the mouse driver from the Windows 2.03. Okay, so we've now copied the Windows 2.03 mouse driver in there. That should now mean that it should pick up the PS2 mouse. We'll start Windows again and see if that works. Doesn't seem to be working. I'll just go out and see if we can check the mouse is working from DOS first. The mouse does appear to be working. If we just look at you running the Norton editor, we can see if we use the mouse in Norton editor and actually use the mouse. Can open autoexec.bat. And what we can do now is to comment in the mouse driver here. Okay, so the mouse driver seems to be working there. I need to take a look and see if I've copied the correct mouse driver from the Windows 2.03 and see if we can get that to work. But at least managed to install Windows 1.0 there. I'm just now going to try Windows 2.03 as well. We can install that to a different folder. Okay, so we still haven't got an A drive because we disabled this in the BIOS, so we're going to do now substitute A to. If we now go to A, we can now do setup. Change a little bit. Now what we're going to do this is put this in Windows 2. It allows us to change the folder. Now it allows us to select what type. So I think last time we selected PCXT or PS2. Let's try the PS2 this time. This is the ID we've actually set the computer to. We'll choose CGA again for the moment. British keyboard. And we'll select the Microsoft mouse connected to PS2 mouse port. Finish setup. So that should have installed Windows 2.0. Just type in Win and see if this actually starts up the mouse. The reason why the Microsoft logo doesn't work properly is because the video reading is causing the problem. I think we can see that we've got a mouse pointer there, but again, our video reading problem is causing this interference here, but it does allow us to at least use the mouse. The shows are actually able to get it up and running. Obviously, with the VGA video card at the moment, with its current problems that I've been working on, it's not great at the moment. So what I'm probably going to do is in the next video, I'll look at resurrecting the CGA video card that I was working on. I'll actually get that installed and working, and hopefully when we come into here, we'll actually be able to see the screens looking a little bit better. I was hoping to also try and get the VGA working with colour for Windows 3.0, so I'll also look at that as well. So I've managed to get the PS2 mouse working and managed to run Windows 1 and 2. I'm not going to do 3 at this point in time. Now, although I've sort of not really been able to get the VGA video card working successfully, it works to a certain extent, but the reading the video RAM seems to be the main problem with this. So what I'm going to do in the next video is look at resurrecting the CGA video controller that I was doing earlier on in the series, and I will look at getting that installed and see if we can get some better images out of Windows. This is a test image that we started the video with. It's now a lot cleaner and looking a lot better. It's not perfect, but at least when it doesn't scroll, then everything looks okay. So thanks for watching. If you don't want to miss out on future videos, then please hit subscribe. If you can hit like as well, it just helps to make the videos available to more people. Thanks for watching.